Who are the characters behind science? This is Science Behind the Glass, illuminating the human side.
In this podcast, we unveil the human side of laboratories and science. Scientists share personal experiences and will discuss their meanings from different perspectives and fields of research. Welcome to Science Behind the Glass, Illuminating the Human Side, the podcast where we explore how science and human stories connect to make sense to our world. Today we delve into the fascinating relationship between sensory systems and the natural environment, from the hand of an expert who has dedicated his career to understand how organisms as diverse as insects, arachnids, and electric fish perceive and adapt to their environment.
Our guest is Dr. Jorge Molina, Associate Professor at the University of Los Andes, Colombia, with an outstanding career in neurobiology and sensory ecology and a PhD of the University of Göttingen in Germany. His research focuses on how sensory systems allow organisms to survive and thrive their natural habitats. Dr. Molina has made significant contributions to this field and was recently appointed as a corresponding member of the Colombian Academy of Exact, Physical, and Natural Sciences, in recognition of his impact on Colombian science. Behind the laboratories, Dr. Molina combines scientific rigor with a deep respect for biodiversity and local knowledge, offering a unique perspective on the intersection of science, nature, and culture. His approach not only seeks to understand how organisms perceive the world, but also apply that knowledge to the conservation and sustainable management of ecosystems. Jorge, thank you for accepting the invitation.
No, thank you very much for the invitation, and I am very happy to be able to share with you.
I also have to mention that Jorge was my master supervisor.
Yes, it's been a while.
Well, Jorge, to begin with, we would like to know in general terms what the sensory systems of organisms are and what differences there are between groups of organisms in these systems.
Yes, I think that when we talk about sensory systems in animals, we humans always take a very anthropocentric position, right? And so we always think of smell, taste, hearing, sight, and touch, especially those of us who are such visual animals. I think that everyone has recognized and talked for a long time about the 5 sense organs, and sometimes there are comments that some people have a 6th sense because they foresee things that are going to happen and that kind of situation. But in reality, nature is full of 6th, 7th, 8th, 9th senses that many of us can't even imagine and that are tremendously spectacular. So, I have always been interested in what I call the traditional sense organs, which are the 5 we first mentioned, but to begin to understand a little bit about the others is very interesting. And to that extent, I have also been trying to get to know a little bit about those sensory organs, such as electroreception, which is the ability to detect electric fields, magnetoreception, the ability to detect magnetic fields and to locate oneself. I always say that this should be spectacular for many people because many of us get lost. We enter a shopping mall and we don't know where we came in, and we went around twice and we are already lost. So, magnetoreception should be very interesting to be able to return home without problems, and there we could stay talking about many others. For example, another sense that I really enjoy is everything related to touch and vibrations. So, I have always believed that the 6th, 7th, 8th, 9th, and 10th sense organs exist, and that we do not know them, but that does not mean that they cannot be explored and studied.
Oh, that sounds super interesting. And how did you become interested in this field, and what keeps you passionate about understanding how organisms experience the world?
Well, I came to sensory ecology by accident. Basically, I finished my undergraduate and graduate studies at the Universidad de Los Andes, here in Bogotá. And after finishing, I started looking for possibilities to do a PhD. And during my undergraduate, of course, at the Universidad de Los Andes, we had several German professors who taught us several disciplines, and the rigor and everything that, is classic of the German system, for example. And so, when I finished, the only thing I knew for sure was that I wanted to continue working with insects, which is what I dedicated most of my time to during my undergraduate and master's degrees. During that time, I worked with insects that transmit diseases, So I was very much a parasitologist and very much into insects that transmit diseases. But I said, I'm going to open myself up to the possibilities. The only thing I'm going to restrict is that it be insects. And so I started looking for graduate programs, and Felipe Gul, my professor at the Universidad de los Andes, put me in touch with someone at the University of Göttingen, a Colombian woman who was living and working at that university, out of kindness and likely out of solidarity with fellow Latinos and Colombians, began reaching out to all the professors at the institute where she was based and asked them what possibilities there would be to receive a Colombian. And then appeared what in German I have always said is the most beautiful word, which is not the PhD director, but they call him Dr. Vater, and that means the PhD father. Vater is father and doctor. Well, doctorate. So surely for some people who have done their PhD in Germany, the father has been quite bad. But in my case, the father was exceptional. I have said that Andreas Stupner, who is my professor, because he is still alive, he became my father, and so he received me in his house when I arrived in Germany. He had me for a couple of months. Then he helped me with the first things in German that I should know, and he was teaching me all the basics about sensory systems. And the first thing he did was to put an insect exposing the central nervous system. Then he introduced an electrode and told me to talk, and I started talking, and this insect was a cricket. So it had ears in its legs, and I started talking. And as I talked, I saw neurons on a computer screen moving. Well, the action potentials of the neurons. And I said, wow, this is wonderful. And that was my first encounter with sensory ecology. I could stay here now just talking about the wonderful experiences one has with one's Dr. Vater in Germany. But the next interesting step was when I was finishing my PhD, and they said, well, why don't you look for a postdoc? And so I started looking for a postdoc, and then I was working in my lab, and the top leader of that lab, who was not my professor, comes up to me and says, do you know Vienna? And I said no, and he said, why don't you go live in Vienna? Look, I have a colleague there who is working with spiders and vibrations, and he is looking for a postdoc in electrophysiology, and, well, you know about that. Go and talk to him. And he is none other than Professor Frederick Barth, who is the expert in spider vibrations. And he had a way of seeing the world, or has a very particular way of seeing the world. And that is, not everything is biology. You have to mix it with chemistry, you have to mix it with physics, you have to mix it with mathematics. And at that moment the world opened up to me and I said, wow. Of course, that's what they call sensory ecology. It's not just biology, it's understanding that the physics you studied is also useful, that the chemistry you studied is also useful. And that's where I became interested in sensory ecology.
How did you get to Los Andes?
Los Andes was also a total accident. I always say that my life has been full of accidents and the chance that biology is classic. But I came to Los Andes because when I finished high school, in my time as a child, as a young man, well, there wasn't what young people now have. All those psychologists who analyze them in high school and tell them, look, your best qualities are to be a lawyer, or to be an architect, or this kind of thing. And in my family, everyone is a doctor or an engineer. So, I was clear that engineering was not my thing. And what I was clear about was that I liked research, and I thought that doctors did research. And since the rest of my family are doctors, I said, well, I'm going to study medicine. I applied to medical school, and I didn't get in, because I wanted to study medicine at a public university in Colombia called the Universidad del Cauca, which at the time trained and surely still trains very good doctors. So it was very strict and very difficult to get in, and I didn't get in. And so they said, why don't you go and study for a degree in biology? And then you can switch. And I was like, a degree in biology? What's that? And, well, yes, as it seems to be like to go and teach children, young people. So I said, well, let's start and see. And when I saw what I liked was not the teaching, but the biology, and I said, those who do science are biologists, not doctors. Some doctors may do it, but biologists are dedicated to it. So, as I was at the Universidad del Cauca, I did 3 semesters there, and I told my parents, no, I'm going back to Bogota, and I'm going to start looking for a university. And I also thought about the Universidad Nacional de Colombia, which is the best. But at that time, It was on strike after strike. So I said no. It's one thing to know when you're going in, but not when you're going to finish studying seemed terrible to me. I have always had problems with the Universidad Javeriana for religious reasons, so I didn't like it. So by elimination, I entered the Universidad de los Andes. And to biology too, as you can tell, by an impressive accident of life.
Very curious.
Yes, it's all very curious, really, if you think about it. I mean, it's all been accidents, go to Vienna, and just there I meet another person, go I don't know where, and there's another person and all, what else? The most spectacular. I think biologists are full of meeting spectacular people in different places.
To get into this subject, part of your work is the study of electric fish. What fascinates you about these organisms in particular, and what can we learn from studying them?
This is one of those sense organs that is difficult for us as humans to understand. But I think the easiest way to illustrate it so that someone listening to us can begin to internalize it is to imagine that we get into a swimming pool and close our eyes, which is almost unthinkable for a human. Well, the vast majority of us close our eyes when we jump into the pool, but imagine that we don't open them again and we start swimming around the pool. And suppose that pool is full of obstacles. Obstacles like rocks, and obstacles like other animals that are moving around. Well, if I'm human and I close my eyes, I'm probably going to end up crashing into most of those rocks and a lot of the stuff that's in there, and I'm going to end up coming out saying, I don't want to go back into the pool. But if you start to imagine that there are fish in Africa and South America that acquired the ability to change their body muscles so that they can no longer contract, but the moment a motor neuron tells the muscle to move or contract, and that cell lost actin and myosin, which are the proteins that allow muscle contraction, well, the cell is not going to be able to contract anymore, but it is going to move ions. And in that movement of ions, if I put several of those muscle fibers together, what I'm going to do is like putting several batteries together in one of those old flashlights that some of us probably saw at some point. Not the new LEDs. The old ones that were an incandescent bulb and you had to put 3 or 4 batteries in a row for it to learn. It's the same thing. If you put several of those batteries, I call them batteries. But let's say they are muscle cells that have lost the ability to contract muscularly. Well, now you have a dipole, and a dipole with a very small voltage, but which nevertheless extends throughout the body in all 3 dimensions. And if you now close your eyes as a human, and had that ability to not control your muscles, but to produce that field around your body, as you swim, rocks, for example, deform the electric field you have around you, and so you could avoid them. And if you get close to another animal, for example, that concentrates the electric field in the body of the animal, of the fish in this case, of the human that is swimming, and so I know that what is in front of me, or what I have around me, are animals that I can avoid if they are very big, or that I can consume if they are smaller. And the most interesting thing of all is that if I am in the pool and I have a rock in front of me, with this sense I can know what is behind the rock, even without going around it or looking over the rock. That is the ability that this sensory system gives to fish that are in the environment. And that is spectacular for animals that are active at night and that live in murky waters, which is what the theory says. And that is why these fish have that ability to move in environments where they could not do it with their eyes or with other systems.
Wow, I'm not very familiar with that. I do recall we worked with electric fish in Uruguay, and it was really fascinating to detect them since their voltage was quite low. But of course, it makes you wonder, what is the difference between them and the electric eels? This seems so much more dangerous. Could you clarify the difference between those with low voltage and others like eels that pose great risk to humans?
Yes, these fish that I just described to you, and this situation that I just described to you, are called weakly electric fish, precisely because you can be in the water with them and nothing will happen. They are millivolt discharges, very small microvolts in some cases, depending on the conductivity of the water. Only if you are very close to them, you could actually find them with the detector that we get into. But electric eels, and other fish, for example, that live in the oceans, also did the same thing. They lost the contraction of their muscles. There is one, for example, very interesting, which is the Astroscopus, which lives in the Atlantic. and what it did was the muscles of the eyes. Now it does not move them, but it produces impressive discharges. That one can kill you. That's what I call the fatal gaze. I mean, if that fish looks at you, it can fry you in one go. The other one is in South America, the electric eels, which many of you have probably seen at some point or have heard stories about, 2 meters long, that live in many of the streams and rivers in South America. And of course, you look at these animals and they are impressively long, and what you have to imagine is that less than the anterior tenth of the animal's body is the body itself, that is, all the organs that we have in our abdomen. The animal has it concentrated in the first tenth, and in the other 9 parts of the body are muscle cells, batteries, as I just described, joined together, and then that, of course, does not produce millivolts or microvolts, but full volts. And if one of those knows that volts are not what kills them, but amps do, and that there is a direct relationship between voltage and amperage, well, the more volts, the amperage is going to be very strong, and it's going to end up causing me impressive damage. And that animal, the eel, when I'm looking for my weak electric fish, if I pass by and detect it, I usually tell the students, let's not come around the other side. Let's leave this animal alone. Clearly, it is only going to be aggressive when it feels that you are invading its territory, or that you are, putting its life at risk. It is an animal that also tries to avoid you, but something unexpected can also happen, and that is why it is better to avoid it.
Are these animals blind or their vision is limited?
No, they have very good eyes. Even now, we are trying to publish a paper where we show that most people who work in this field say these animals that live in the dark and in very, very sediment-filled rivers, so they don't need their eyes to see. But in reality, what we are going to show with that paper is that they have very good eyes, that they have very good capabilities, and generally, if you look at the eel, it has quite large eyes. In other words, it is not that they don't use them, they do use them. And a lot of people think that by using that electric field, the eyes go to a second level, but that's not the case. They actually use them quite well. And there are all sorts. There are some that have small eyes, others have larger eyes, and what we are trying to show in that paper is that it is proportional. Those that have small eyes, then they do certain things, and those that have large eyes, well, maybe they do even more things.
Yes, and what do you think, for example, we could extrapolate as humans from the special sensory abilities that you have told us about, both from electric fish and from other organisms that have these abilities that are not the same as humans?
Yes, I always use this anecdote to illustrate the situation for you to see, which is Plato's allegory of the cave, which you read probably at some point when you study philosophy, and it is about the prisoners who were tied up in a cave and could only see images that were projected past them, which were shadows, and they believed that that was the real world. That is what we believe with our 5 sense organs. Many humans believe that those wonderful flowers that we see, that is the wonderful world, and the smells that we detect is the wonderful world, and many of the sounds that we hear is wonderful. But I always say, imagine that you had that 6th, 7th, 8th, 9th sense. The world extends even further. So, it is as if those prisoners were released, which is what happens in the allegory of the cave, and they go out and see that not everything was shadows, that there are many colors, there are many other things that you never imagined existed outside. The same would happen to us, and not only if we had the ability to extend those other sense organs, but the ones we have. For example, our eyes only see visible light, but there is infrared and there is ultraviolet, and other animals see that. Well, not infrared, because you can't see it, but ultraviolet. But if we could see in ultraviolet, we would see things totally different from what we see today. So it has always seemed to me that studying sensory ecology is what biologists do to expand that external world and understand that outside is as if we were coming out of a cave after being tied up. It is tremendously impressive what you can see and what animals can do with their sense orders.
I'm following up a bit on what you are saying. How can we learn about that adaptation and resilience by observing nature in a world that presents so many environmental challenges, specifically from the point that you study?
Yes, that is very interesting what you ask, Linda, because if you think about it, the world is very changeable today. Well, it has always been changeable, but now what we are doing is accelerating the changes. And a very interesting point is to think about how the sense organs can respond to that acceleration in changes, right? That is another completely different area. I am just now trying to start with a student that we are going to try to see during his master's degree. The effect that the increase in carbon dioxide concentrations has on the olfactory abilities of certain pollinating insects. I am almost certain that what that is going to show us is that, depending on the insect or animal you are working with, there are certain capabilities that can be extended, and the ability to adapt is going to be, in some cases, quite fast. In others, no. Surely those are the animals that with sensory systems that are not able to keep up with the accelerated pace of the process. Well, they are going to have to step aside and surely will not be able to continue passing their genes on to the following generations. But there are many others that are going to have the capabilities to have the responses to those accelerated changing environments. And surely those are the ones that are going to play a very important role in the generations to come, or in the times that await us next with all this change that we are undergoing.
And we can also extrapolate that to what is happening to us, right? If it's happening in another animal and it reacts or changes quickly, we can also see it in how it's going to affect us, how it affects not only our senses and how we are going to live, right?
Exactly. And of course, well, it is. Animals, I have always thought that they have, not only animals, in reality, fungi, plants, bacteria. Bacteria are extremely amazing in their ability to respond to change. I think so. In many organisms, it is very possible that these kinds of things can happen, as you say, not only at the sensory level, but in other systems as well.
And you were telling us a little bit about how they are discovering precisely, or how you are discovering precisely that these fish that were thought to be half blind or had a poor vision, it turns out that they are not. Are there any other discoveries or results of your research that have surprised you or that you have found impressive within what you have studied? That's very good. Nice.
Yes. Well, I think Linda will like this one a little bit. And I don't know if I ever told her when we were here or not. But, for example, when I was with Professor Barr working there with the vibrations of spiders, there came a time when I said, I am feeling more vibrations than most people do. Because I remember when I first arrived, we were in a building and the tram passed by nearby. And the tram is a train that is moving and creates certain vibrations, and we are like on the third floor of the building. At first, I didn't feel it, but in the end, after working so much with the spiders, I was already beginning to feel, here comes the tram, even because I was already feeling the vibrations of the building, and you could look at the other people and the other people as if it didn't impact them, or they didn't really feel the vibrations of the building. So I think that when you get into the sense organs and begin to understand animals, you also begin to say, I'm not so bad at hearing. I'm not so bad at feeling vibrations in the ground either. What happens is that as humans, we are too visual, and we rely too much on our eyes, but too much. We leave almost all the sensory responsibility to our eyes. And that is why people who lose their sight are tremendously successful also with their hearing, with their sense of smell, because we are really not that bad. In reality, we are good. What happens is that we do not take advantage of the potential we have. So, I think things like that have caught my attention that I have discovered is how the different animal models I have worked with have taught me. I have already described the fish to you, but, well, that is very difficult for us because we are not aquatic animals, and, well, electroreception in air is very complicated to think that you are going to feel it. But yes, studying, for example, smell in insects, smell in other animals, infrared now that we are working with snakes, all that begins to attract your attention and to see that we are really not so bad and that we have a lot of potential as human beings.
It's like studying these animals sharpens your senses. For instance, you and I both wear glasses, and I have contact lenses right now. But even without them, I still can spot the spider webs. People often ask me, how do you see that? And I just point to the web. It's funny because I can't see people clearly from a distance, but I can always see the webs.
That happens. And I think the advantage that those of us who do sensory ecology have is that it is as if I exploit my sense organs more and try at certain times. For example, I bother the students here in Colombia. I don't know how it is in the different countries where you are now, but here I tell them, look, it is that economists and those who manage businesses also manage you. You could walk blindfolded through the stores, and each store smells different. And there is a logic to that is leading you to buy without realizing it. We are truly bombarded with too much sensory information, and we don't pay attention to it because we rely so much on our eyes. So what Linda says is true. I mean, because you are fascinated by your spiders, you see the things that spiders normally do, but for most people that goes unnoticed, and well, I see things and hear things and smell things that surely for most people are not very normal either, because the insects or animals I work with have called my attention to that.
And through your career, you have also worked with various species, including electric fish, spiders, fungi. Is there a moment or discovery that has surprised you or challenged or changed the way you see science?
I think the one that has impacted me the most, and unfortunately we have talked a lot about it, is the electric fish, really. That marked me a lot. But if I were to leave that aside so as not to keep talking about the same thing and be able to tell other experiences, for example, I was very fascinated by the work I did with spiders and vibrations, and during my doctorate I worked a lot. It was with auditory neurons of crickets. So it's like, it struck me. Imagine a jungle, which is what you can't imagine either. Many biologists do, because we are sometimes in them and we imagine it. But imagine being in the Amazon and having to find your female in order to reproduce. And you have to do that just by singing. And many times in crickets, it is only the male that sings, and the female never sings. In other words, you are singing all night long, and that is why you hear so many crickets singing at night, because you are attracting a female, and you don't know if that female is hearing you, and if she is going to come, and if she is going to reach you, right? So you have to sing and sing, because if you stop singing, well, there is less chance that the female will arrive because she will simply be able to arrive by phonotaxis, by the sound. The moment you stop, she gets lost, and if another male sings on the other side, well, the female deviates and goes to the other side, so you can't stop. If you stop, you lost everything you've been singing, so there's no way to stop. And now we don't imagine that in 2 dimensions, that is, in 2 planes. But what happens if now you are in a tree and the female is below the tree and the female has to climb up? Then we put 3 dimensions into it. So sound in 3 dimensions is an impressive thing. And let's think that I am not the only one singing, and there is not only one female, but there are another 10 or 15 of my own species also singing, and behind the same female or behind other females. And to complete the story, then there are also bats that are hearing me and are willing to eat me. So the story becomes kind of creepy too. And to top it off, there is never a shortage of freeloaders, which are what are called satellite males in crickets. Well, they are males that are afraid of bats, so they don't sing, but they stand near those who are singing and intercept the females. The poor guy who is singing never knows that others took his female and the female was looking for you. But since another one got in the way, she stayed with that one. So what? Nature teaches you is that out there things are pretty terrible, that it is not as tasty as most people imagine it to be, and that was also taught to me by my work during my doctorate in Germany.
That's very good. Nice experience.
I also remember that there are crickets in Hawaii that when they sing, they attract the parasitoids. So they feel super attracted to the males when they start singing.
Exactly. So it's not just bats that are the problem. There are also flies, There are also wasps. Mainly flies are also the ones that are parasitoids that also arrive and take advantage of the fact that you are singing and they go and leave their eggs there, and you enter a situation that is no longer predator-prey, but parasitoid, which is an even worse situation.
Part of your work, you are a mentor to new generations, to students of different degrees, both undergraduate and graduate, right? What values and principles do you think are the most important to convey to young people who are starting out in research?
Well, I think at the beginning, Linda, when she made the presentation, she said something that has also marked me a lot, and that I try to follow to the letter, and that is rigor. Sometimes you get excited about the results, but then you say, well, but let's wait. Let's see. Is that really the case? So I think being rigorous is one of the things that is important. And it is one of the things that I try to convey to the students that I have in my charge, even those to whom I teach introductory courses. The other thing I teach them, and that I think is very important, is that, to me, I'm going to tell you, I've told it many times, it's not a scoop for you, is that I went into biology because I hated math. And associated with mathematics, well, comes physics. It's like the older brothers and the younger brothers. But if you hate one, well, you hate the other by default. I've always liked chemistry. I've always been fascinated by chemistry, and that's a good thing when you're a biologist. So I always emphasize to the students, pay attention to your chemistry classes. You think that's just something you have to take the exams, get out of there, and forget about it as quickly as possible. But no, it's important. And when I got into sensory ecology, I said, oh, physics is important too, so I had to start paying attention to what I had never paid attention to before. Ohm's law, voltages, resistances, currents, all that kind of stuff, accelerations, speeds, waves, well, all that stuff that you say, I wish this would go by quickly and I'd get out of this and never have to go back to seeing this again. I tell them, in reality, if they teach it to you in college, it's because it does work, and it's important. At some point, it can make the difference for you to decide, oh, look, I didn't know about this area, and now it turns out I'm interested in this. So what I also try to tell them is, besides rigor, physics, chemistry, mathematics is interesting. And the last thing I tell them, well, I'm old. I've done a lot of things, and I've done a lot of things just with Excel, but most of you can't do your thesis with Excel anymore. Now you have to learn to program too. So, many of you are going to have to, like it or not, learn Python, learn another operating system like that, and learn to program. R. All that kind of stuff is already part of a biologist's life. So, the biologist is no longer just looking at what animals do and how animals do it, but also thinking about physics, chemistry, mathematics, and learning to program. Because each time the theses demand more complex computer systems and analysis that can no longer be done with Excel. So, what I try to promote is a lot of that, and that they try to do it, and that they get into it early, so that biology doesn't run them over later at the speed it's going.
And I must add that something I learned from you was to be objective.
Well, that is tremendously important, Linda. When you arrived, well, I have always applied it, but I thought that was very normal, but it seems that it is not very normal. So, well, you once made me realize that, and I thought that was normal.
Exploration also involves a lot of field work that you were telling us about. Going to rivers, looking for fish, and depending on your object of study, of course. How do you collaborate with local communities when you come to work to combine scientific knowledge with traditional knowledge?
Yes, I think that is very important, and more so in places like Colombia. And I always tell the students when we go on field trips, look, we are passing through this city and this small town, and we are going to go now to a farm. And the vast majority of people, what they see is, there goes a big bus with some people that we are never going to see. Get off here. That they go to a place. They do something. They get on the bus. We see them pass again 3 or 4 days later, and we don't even know what they are doing or who they are or what they did. So I always tell them, it can't be like that. We have to give something back to the people who live in those places. So, for example, in the plains where I now work with electric fish, If we launch ourselves towards the east of the Andes, we quickly descend to a very flat place that is what we call the Eastern Plains. And in that region, well, obviously there are populations that work in the countryside, live in the countryside, and who see that occasionally we arrive, we leave, and they don't know what we are doing. Well, what I tell them is, let's do something for them. Let's go to the schools. So I like them to invite me. So I talk to the owners of the farm who are also from Bogota. But they live with the people who manage the farm for them, who are residents of the area, who are very active ecologically and culturally in the area. So I tell them, hey, invite me. So they have invited me to the schools in the area to tell them about the fish. To tell them, once it was interesting, in that place they are very interested in birds. And then they said to me, hey, and how do you give a scientific name to a bird? So I said, well, I can tell you. So I went and told them, well, where the scientific names came from, and that the scientific names are in Latin, but what the scientific names try to say are the physical characteristics in some cases of the birds. So, pyrocephalus, firehead, and then you look at it and it really is a bird that has a red head. So, well, of course that's why they called it firehead, but, well, we can't call it firehead in Spanish because that's not what is used. So you have to say it in Latin, and that's pyrocephalus. And I was impressed to see that they were taking notes on everything I was saying, as if we were in a class and I was saying, how wonderful. Sometimes I even said they are better than my students at the university, they are paying more attention to me. So, I think that's what really catches people's attention, and that's what you have to do. People in the countryside pay close attention, and are amazed to see that someone comes and wants to tell them something about what you do, and that they have never seen or imagined it, but that they live with it all the time. So, I think it is important that part of interacting with the communities, and that they are not simply a means of passage, and that nobody wants to interact with them.
Yes, it is reaching other audiences and how to connect with them. This is super important.
And as we were talking about it one day with other people, it is not about lowering the level. It is simply about putting it in simpler words. One can explain electricity in simple words, and I am not lowering the level. That is, I am not hiding from him that a fish is electric, I am telling him. But then I have to explain to him with electricity really how the thing is, but not talking about Ohm's law. Because, well, that is taking it to a complex situation. But yes, I can explain Ohm's law in a simpler way, and easily the person can understand it without me taking away the strength and all the academic part of what I am telling him at the time.
Yes, I have always said that if you are able to explain in simple words, without oversimplifying things, you understand the concept deeply. It is the best way to explain it. And we know that you were recently appointed correspondent academic in the Colombian Academy of Sciences. First of all, explain to us what this means and what this recognition means to you and how you hope to continue contributing to scientific development in Colombia.
That was another one of those anecdotes that I wasn't expecting one day. Felipe Goul, one of my professors at the university, with whom I worked in the same parasitology lab, invited me and said, I'm inviting you to lunch today. So we went to lunch, and during lunch he said, listen, I want to propose you to the Colombian Academy as a corresponding member. Imagine I immediately said no, but I still have a long way to go to get there. So he said, give me the papers and I'll take care of the rest of the process. And indeed the surprise was when they told me that I had to meet certain requirements, a publication and other things to be able to enter as a corresponding member, and then comes the whole ceremony and the whole process, which obviously, as you can imagine, well, academies are a whole tradition, and that tradition is spectacular of the whole process, of knowing that this comes from very ancient times, when scientists began to organize themselves in the world. So there are very old associations. There are others newer. But in Colombia, this one is relatively old too, and to be part of that tradition is tremendously interesting. But what you don't imagine when they appoint you, or when they appoint you a member of an association or an academy of these, is that now you also have a commitment. Many do not take it that way. Many of those who are appointed members of the academy do not take it that way. But it seems to me that the commitment is, well, now I not only have to do science, but also help to disseminate science. which is what we were talking about a while ago, right? And then it is no longer just thinking that in the cities or small towns that I pass through, you have to go and talk to the people of, but you also have to talk to the people of Bogotá, who are many, who do not know about science because they have not been able to interact with scientists. So we have to help transmit that science as well. And then you think not only in small cities far from Bogotá, but also in big cities you have to do it. So that yes, that has meant that sometimes they invite me and I say, why are they inviting me? Then I found out, and it's because, oh no, in the academy they said no, invite this academician to go and do this in his city. And so that's how you really go about helping. And I say that you acquire more commitments by being an academic. But I also find it interesting to do it, because it's really getting into that logic that we have to promote science in Colombia, and the only way to promote it is for scientists to talk to the rest of the people and let them know what for us is very normal. But for the bulk of the people, it is not.
Well, you are doing it here with us.
I am doing it, but thanks to the fact that you also have a different vision and are truly motivated for people to know not only what we do as scientists, but also that we are people, and that also seems very cool to me.
Things you like to convey to your students. But like many of us who have had the opportunity to teach and give classes, this experience goes both ways. What have you learned from this experience of teaching and mentoring students?
The pandemic changed me a lot. When the pandemic arrived and we had to start doing virtual classes and that sort of thing, I had a tremendous shock. I'm not going to say now that I'm the person who exploits the most virtuality and all the tools available at the moment to reach students, but it changed me in the sense that I said, for example, I'm going to start using fewer slides in class and try to talk more in class and interact more with students. Because what I realized was that you became a person who stood there and recited a story that you've been reciting for 10 years because they're the same slides, and suddenly you change some things to the slides because the ideal is not to become outdated, but you know the story and you tell it, and you tell it, and you become a machine gun shooting and shooting words, and almost you don't even pay attention if people are paying attention, or if they are managing to follow the speed of the words you are saying. And what I realized is that the moment you stop using slides and start using the blackboard more, what I realize now with the introductory organism course is that people talk more and ask me more questions. I have noticed, and unfortunately I didn't start documenting that, because that's another thing I like to do, is to publish what I do in class. The innovations I make in teaching. That did happen to me. I never imagined that the pandemic was going to come and wake me up in that way, so I never documented it temporally. But I clearly have it quantified in my head that before I could spend an hour and a half talking, and nobody would ask me anything. And I would leave the class, and I would say I already did what I had to do. They didn't learn. It's their fault. Now it's very different. I talk in almost every 2 minutes. Someone is asking me something, and I try to make the activities much more interactive. And so many times I don't answer, but I return the question to see if anyone can think of something. And that way you manage to involve many more people, and the classes become much more interesting. And above all, you take away the burden of whether the hour and a half is up. And I didn't manage to get to this. It doesn't matter. I can do something else later to cover the subject. But before it was not that I have to cover these 60 slides in the hour and a half and whatever, so I talk faster. If I look at the clock and I have 20 minutes left, then I have to say them faster. And that's a burden that you don't have to take on, and the student less so. And for the student, it's terrible that you're talking to a machine gun from here. You can't keep up with the speed of what you're saying. So, I think that not necessarily everything has to be very digital and innovative and very much that kind of thing. Going back to the blackboard is also a good way for students to interact much more with teachers. That's what I've been doing recently.
Wonderful. That's a very good strategy. Thank you very much, Jorge. And finally, what message would you like to send the general public?
I think what I mentioned a moment ago seems to me an interesting term, and it is, I hope someday, sometime in some activity you are doing, close your eyes and let your other sense organs take control, and you will realize that the world is tremendously wonderful, and that many things sound that you have never heard, that you have never paid attention to. You don't have to go to the sea. Basically, the pandemic taught me that too. We did it here, record your city from the window. We did it here in Colombia. And then you start to hear things that you didn't hear before, because you come and accelerate from Bogota, that you don't pay attention to anything. And the big cities, all of you wherever you live, you have surely seen it, that you don't pay attention to what is sounding, but if you close your eyes, you start to hear different things, not different, things that have always been there, but you would never have heard them and you have never paid attention to them. So the recommendation I would make and the message I would leave is, let's get out of Plato's cave, and the only way to get out of Plato's cave is to close our eyes for a moment, and let the other sense organs take a little control for a while, and you will see what is impressive, what happens around each one of you.
I completely agree. It's about pausing for a moment, listening and tuning in more deeply. Thank you so much, Jorge, for accepting our invitation and for sharing all these fascinating experiences with us. And of course, thank you for answering all our questions and explaining everything so clearly.
No, thank you very much, Linda and Daniel, for really thinking that I could be interesting for this very interesting work that is so important, because it is not only interesting what you do, but very important. So I really appreciate that you considered that I could contribute something to that wonderful work that you are doing. Thank you very much for thinking of me.
Of course. Thank you very much.
This podcast is fully self-funded and self-edited by your dedicated host, and we rely on your support to grow. You can help us spreading the word by subscribing, sharing, and leaving a review. Find us on YouTube, Spotify, and our official website, www.sciencebehindtheglass.com. Follow us on X, Facebook, and Instagram for the latest updates. A special thanks to our friend Bernardo Aguila for the original music, and to our promotions manager Rafael Jordan for his invaluable technical support. Let's keep the conversation going.